Okay, kidlets, a little more continuation on wetlands. Is really quick here. We talked about how there's types of wetlands, maybe where they form, that kind of stuff. Now, how we study wetlands. There's a term you need to know if they're hydrology, the influence of water. Got that right there. And it can be studied many different ways. And one is by looking at the hydrologic signature of a wetland. So what this little box to the right hand side means right here is that could be just an average wetland. The arrow is going in and out. So coming down in, that's rainwater. Going out, that's evapotranspiration or water going into the air, excuse me. And then this would be water running in and water running out like in a stream. One thing that's missing in here is water coming up from groundwater or water dissipating into the ground from groundwater. Okay, so that's hydrologic signature. The next slide. I'm not really so much on these right here. Don't worry about it. We're going to move on with this right here. We're moving on here. Now, some of the cool things we can do with this stuff is how we can actually measure this stuff. Now, in wetlands, what they'll do is really simple. Number 2 is the easiest one of all. You simply dig a hole down in the wetland, and you can measure the water level variations all the time. You can determine it's a wetland. It's going to be 1 meter within the surface to be determined as a wetland, and you can really record what goes on with the water table at different times. And think about it, rain, evaporation, a hot summer day, those wetlands are going to change dramatically. The best way of looking at it is this thing on the right here. That is a water table recorder. Those are really cool devices that you can see. There is a pulley. Oh, I can't, my shoulder. Oh, right there. There's a pulley with a string on it that goes down to a float down into the water. And what happens is it records the level of water 24 hours a day, 7 days a week. And it's really cool. You get this like complete data list of what happens when it's really sunny, when it's rainy. Everything works really well as far as determining what goes on in the wetland. Now, if we had our semester projects, that'd be something really cool for somebody to do. The last one is something called a piezometer, which is nothing but a pipe stuck in the wetland, and it measures the water level pressure way down below. If you stick it way down at the bottom, water comes bubbling out the top, you've got high pressure like in a fen. It's a good way of measuring the pressure in a wetland. Okay, and then the soils. Soils are in 2 groupings. You've got this mineral soil. It's kind of written poorly, less than 12 to 18% organic carbon. So it's very minerally. You don't have a lot of organic matter. Or you do have organic matter, but not nearly as much as these guys here, where you've got these histosols, where it is 12 to 18% more or more. Technically, it should be 18% or more. And there's several types of those. And the idea is with these guys here, oh God, I wish on that field trip I'd show you. It is literally fibrous, or, you get the fibrous type of soil. It's literally looks like plant chunks. There's hardly anything there. And you can remember soil is made up of organic matter or minerals. And so the fibrous are almost just undecomposed vegetation. And what you end up having then is, like I said, this huge, you can have mounds and mounds of undecomposed vegetation building up over time. And wetlands can be really, 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 really old. Really cool was that my dad had the farm pond dug out right next to the barn 40 years ago. And it was like 3-4 feet deep, but they dug down like 20 feet deep to try and get, deeper so they could have the water stay there and not flood the field out. They got down about 20 feet and they ran into a clay layer that beneath it, we found absolutely 100% preserved big old fern fronds all pasted together, looked like a bale of hay. All pasted together. We found what we eventually identified as tamarack logs and tamarack pine cones all through that area, all because it did not want to decompose. It was really cool. You talk about fibrous type of soil. It was really amazing. We still have some of those somewhere. Now, a lot of times underneath underneath wetlands, to keep all that water in there, you get these limnic deposits. So this right here, this is a clay layer that is really, really thick. That's an old wetland somewhere. That clay layer is really, really gooey thick. That down the field trip we'd see or went to, we would see this really gooey layer underneath, and it was so blue that would actually work to seal everything into the wetland. And you could probably use it for making pottery or clay with, or, you know, pots with. Now, I have this video clip right here. This is from a movie I watched one time called Beneath Hill 60 in World War One. The Germans and the British dug underneath each other's, dang it, dug underneath each other's trenches. And this is actually how they could tell how deep they were, is because in the video, in the movie, it's the short clip, you will see where that they can tell the blue clay, they got down to a certain level underneath the German lines or the British lines, they could see because of the clay they were digging out. Kind of cool. Other than here, we have diatomaceous earth. I don't know if you remember from biology, diatoms, the little one-celled protists that have shells. That will help to keep stuff in the bottom of wetland also, keep underneath here too. And marl is nothing but, well, water that's high in calcium carbonate. When it evaporates, it'll leave a lot of that marl behind. And all these things help to keep a wetland. Okay. Now, this is the part we probably should have done right away at the beginning. This is a statement right here you need to know for sure. Anoxic conditions retard decomposition. Now, what that means is that if there's no oxygen, there's very rarely decomposition. And these wetlands, it's like with the fen and all these different things, that if you have all these things in a wetland with a lot of water, the water keeps it from, and cold water, it keeps from decomposing. There are situations where they have found bodies in wetlands that, oh, somebody was drowned or somebody was killed or somebody was murdered and stuck in here, and they find out that the body is hundreds and hundreds of years old, that you end up having these undecomposed, you know, people or critters or whatever else that have not gone anywhere in hundreds of years because of no oxygen. Now, if you drain the water away and let the oxygen get back to it, guess what happens to all the stuff on top? It starts to decompose. So you get this decomposition, and it keeps wetlands at the levels they are. If you dry out wetlands, boom, you get no more wetland, and you got this really nice decomposing black earth, and you have some really good farmland. That's why it was a huge battle to keep guys from, or people from, you know, draining wetlands. Anyway, going back to the whole, you know, idea of not decomposing anything, is that we got this right here. Now, there's a video I have in here about mammoth remains where, I can't remember the clip that I put in there, but it was all about how some of these remains are so old, we're talking tens of thousands of years old, because nothing will actually, you know, nothing will actually decompose. And up in Superior, there's a company that actually started pulling logs out of Lake Superior that were sunk 100 some years ago during log operations. They never actually, you know, were brought up. So they're extinct logs, and they're so perfectly preserved because of lack of oxygen and really cold water. I'm going to click on this. I think I remember on this one right here. Yeah. Oh boy, that's kind of scary. All right, yeah, okay, whatever, dude. But anyway, this is the one. Yes, they brought up these mammoth remains in Michigan that, again, really, really well preserved because they're down in the muck with little oxygen. Okay. All right. So anyway, that kind of covers a huge aspect of wetlands, and we'll try and expand on a little bit here more. And we're also going to do, we're still not done with the froggies yet, because the froggies, as soon as it starts freaking warming